Okay, so we talked about last time about polygons in general, and now we're going to hone in, we're going to focus on sets of quadrilaterals. So here I have parallelograms and not parallelograms, and I want you to take a look and see, you may already know from a previous class, but what is the major difference between these guys and these guys? So got a hint for you up here. A parallelogram is a quadrilateral. So we know that this guy is not a parallelogram because she has more than four sides. Um, this guy's a quadrilateral though, and this guy's a quadrilateral, and they are not parallelograms. So if you haven't already figured it out, you have to have two pairs of parallel sides, right? Two pairs of parallel sides. All right, so let's dive into our notes. Okay, so today is February, let's see, it's the 13th. Okay, so a parallelogram, we said, is a quadrilateral, has four sides, has both pairs of opposite sides are parallel. Opposite sides, you may or may not have already known this one, they are the same size. They're congruent. These sides are congruent and these sides are congruent. And opposite angles are congruent. What the snot are opposite angles, you say? Well, they're the angles diagonally across from each other in the parallelogram. So here and here, those would be opposite angles. Consecutive or same side interior angles, same thing, are, you might remember this from previous lessons, they're supplementary, right? Since we have parallel lines, we're going to be thinking a lot about Z's, F staples. So here I have a staple, I have consecutive interior angles that are supplementary. And the diagonals, now this is a new one probably for you, they bisect each other. Okay, so here we go. What I have here is some different examples where we're going to apply specifically the properties of the angles for now. So these two we're going to focus on for now, and we're going to solve for some angles. Now, be on the lookout for sine, cosine, and tan, because we know how to do that now. Look on the lookout for Pythagorean theorem, and on the lookout for 45, 45, 90, and 30, 60, 90 triangles, because these could all be used at any time. Here we go. All right, so you have, let's see, you have 40 degrees here, which means that you can use a Z. You could use alternate interior angles to put 40 degrees here. Then you know that this angle is 90, so that means this remaining angle has to be 50. But by all the angles in a triangle add up to 180. You also have a Z here, so X would have to be 50. And then, oh, again, you have a triangle with 180 degrees. So 90 plus 50 subtracted from 180, that leaves us with Z is 40. So X was 50, Y was 40, Z was 40. Okay, this next one, since these are all parallelograms, sorry, I should have said that. Figures are parallelograms so that you could assume that the opposite sides are parallel. Okay, so you have a staple here, but that's not helpful. Let's see, we also have a staple going this way. Since both sides are parallel, staple can work either way, so 6x plus 12x adds to 180, so 18x adds to 180, or x is 10. And then once you know that, 6 times 10, that's 60. So we know that the staple going this way, 3y plus 60, adds to 180. So 3y equals, when I subtract 60 from both sides, 120, or y is 40. That's all still part of B. What's going on C? You might notice that I have a right triangle here in which one side is half the length of the hypotenuse. Where have we seen that before, friends? 30, 60, 90. Remember that the angle across from 30, you take it, you double it, you get the hypotenuse. So x is 30. Okay, then on part D, you're just utilizing again your alternate interior angles. So angle 3 is 22 and angle 2 is 45. Oh, and then you can use the opposite angles, or you could use the triangles. Either way, 180 degrees in a triangle. I'm going to use my opposite angles because it's faster. Angle 1 is 113. Okay, so I've got 2 U-tries here. You can pause the video and come back and check your answers. Okay, so I got A to be 11 and B to be 55 on part E. Oops. We got the opposite angles you can equal to each other, and then I used a staple by plugging back in 11 for A to get 55. Then for F, you used alternate interior angles going 2 different ways perhaps. You use the opposite angles to know that angle 1 was 115. You could have used 180 degrees in this triangle once you knew angle 3 was 50 to figure out angle 2. Bunch of different ways you could work that. So I'm going to stop this video and you can pick up on the next one.